Howdy, PreCal. It is Miss Kosh, and today we are doing Section 5B, Attributes of Series. And so a series is the sum of the terms of a sequence. So here are a few little things we could look at. On this one, notice on the first one here, we see commas. We don't see plus signs. This is just a sequence. Is it infinite or finite? Well, there are 1, 2, 3, 4, 5 terms. That is a finite number. So this is a finite sequence. It's a sequence right here. And it is, we were adding 4, adding 4, adding 4. This is arithmetic. Okay, the next one is, notice I have 1, 2, so I have 1, 2, 3, 4, and then it keeps going. So this is an infinite, and since there are plus signs, it's an infinite series. And 2 to 4 to 6, that's not what happened. It was 2, 4, 8, 16. This is a geometric series. The next one, I see another sequence. You know what? I'm going to be lazy. I'm going to see another sequence here, and then I see another series here, and another series here. See, the plus signs tell us it's a series. And then we have this one. Let's see, what do we have? We have a finite, so because there are 1, 2, 3, 4 terms there. And we have another finite down here. There are a set number of terms. And then we have an infinite series right there. And now let's look arithmetic or geometric. The first one, I go from 4 to get to 16. I multiply by 4, I multiply by 4, I multiply by 4. That would be geometric. And then the next one, I'm adding 10, adding 10, adding 10. That's arithmetic. The next one, I'm multiplying by 2, multiplying by 2. Oh, let's do this again. Duplicate. That's geometric. And this one would be duplicate, arithmetic. Okay, I don't know if that was faster than me writing the words, but there we go. Okay, so the capital Greek letter sigma in mathematics means we are calculating the sum of the series. And so if we write something, so here's how we read this. We say this is the sum as I goes from 1 to n of a sub I. So the sum as I goes from 1 to n of a sub I. And what this means is we start with whatever this number is down here. We plug it in wherever it shows up. So a sub 1, and then we're going to add when we plug in the next number. And then we're going to keep going, keep adding, keep plugging in integers until we get to the last one up here, and then we plug that one in, and then we stop. Okay, so this series is finite because we had a stopping point. Now, it's the number n or the whatever. We have a bunch of terms. We don't know how many terms we have, but it has a finite number of terms. Typically, we're going to see this with more stuff to do. We'll show you that in a second. The next one here, this series is saying, a sub 1 plus a sub 2 plus a sub 3 plus and to infinity. So then we would just say plus dot, dot, dot. This series is infinite. All right. And then the next thing I want to do is find the sum of the first 100 positive integers. So there was a rather precocious math student when he was young, and he was irritating the heck out of his teacher. And so the teacher was like, just go away. Add up all the numbers from 1 to 100, thinking that he would be out of the teacher's hair for a little while and give the teacher a little piece. And he came back with an answer almost immediately. And the teacher's like, no. Okay. Anyway, so let's see what this rather precocious student did. So if you think about all the first 100 integers, notice, maybe you might notice I wrote the first 3 and then the last 3, because notice if I take 1 plus 100, I get 101. If I take 2 plus 99, I get 101. If I take 3 plus 98, I get 101. And so notice I could keep going and do these pairs as I keep, and you'd notice I would have 50 pairs of 101. And so this total ends up being 5050. And so this will also lead us to the formula for an arithmetic sequence. We took the first term and we took the 100th term. We added those together. a sub 1 plus a sub 100. We added those together, and then we multiplied it by, well, we had, how many terms did we have? We had 100 terms. We divided that by 2, because that gave us, we had 100 terms for 50 pairs. 100 terms led to 50 pairs. And so the formula is actually the number of terms divided by 2 times the value of the first term plus the value of that nth term. And that right here shows up in our partial sum. So this is in our arithmetic formula. We talked about these sequence formulas before. We talked about the geometric sequence before. What's new today are the sums. So these are the finite sums. And so the one we just talked about, this was the one we just came up with, S sub n. So it's the sum of n terms is equal to n over 2 times a sub 1 plus a sub n. Well, now, if you notice, let me show you how we get to this next part. If I take S sub n is equal to n over 2 times a sub 1 plus a sub n, what I can do is I can come over here and say, well, a sub n is equal to this. If I take this and plug it in here, I end up getting a sub 1 plus n minus 1 times d. And I can clean this up a tiny bit. I see that I have an a sub 1 plus an a sub 1 is 2 right here, a sub 1 plus n minus 1 times d. So we can use either of these formulas for the sum of the sum of a finite arithmetic series. One of them will have an advantage over the other often. Not always, but there we go. The infinite sum does not exist. Okay, so if you keep adding, if you have numbers that are consistently getting more and more and more positive, you can't add. If you add up an infinite number of them, it's just going to go off to positive or positive infinity. If you're adding up numbers that are getting more and more negative, your sum is just going to diverge to negative infinity. I have been showing a cartoon that illustrates this point beautifully. I've been showing that cartoon probably for 10 years. I don't know. I watch it 6 times a year, every year. And it's so good, and it really brings this whole idea to light. So I will put a link to that in the comments of this, or in the description of this video. And I'm going to make my kids watch it in class. So it's really good, worth your time. Okay. The next one, so the geometric partial sum, the sum of n terms of a geometric series is equal to a sub 1 times 1 minus r to the n over 1 minus r. The proof for that is a little trickier, so see me later if you want to see that proof. Okay, and then we can find the infinite sum of a geometric series if the absolute value of r is less than 1. Okay, and so that formula, sometimes I just write the sum like this. I just write my rule that way. Sometimes you see the infinity sign, and sometimes I get lazy and don't write it. Those two things mean the same thing. If you want a finite term, it has to have S sub n. Okay, so it's a sub 1 over 1 minus r. Now, with in our sigma, so we can see our series in the sigma notation, it will converge. An arithmetic series never converges. So if it is an infinite series, it will never converge. If it's a geometric, it will always, it never converges, it always diverges. Sorry, that was bad. And a geometric series will converge if the absolute value of r is less than 1, and it will diverge if it's anything else, if it's greater than or equal to 1. And so we'll look through. Let's just jump in and do some stuff. So I started working a couple of the problems to make it go a little faster, but I didn't get very far. I intended to. Okay. On this one, so they're asking us to write the following in sigma notation using explicit sequence forms. Okay. On this one, what do I see? I see that I have a common difference of negative 4. I'm going down 4, down 4. I'm losing 4 each time. And so a sub 1... I lied. A sub n equals a sub 1 plus n minus 1 times d. So I can say a sub n is equal to 15 is my first term, plus n minus 1 times my d value is negative 4. Hang on, let me squish that up a tiny bit. Okay, sorry. And I could stop here. I tend to like it a little cleaner. I would say a sub n is equal to negative 4n plus 4 plus 15 gives me 19. And so this is the sum as n goes from 1 to, we're going to talk about what in just a second, of negative 4n plus 19. Okay, it goes from 1 to, well, here's the first term, here's the second term, the third term, and the fourth term. So it's going from, n goes from 1 to 4. You know what? It would have actually been better. We should do this part first. I haven't taught this yet because I'm making my video before I teach it. So I'm going to evaluate how I'll probably teach it in class a little differently because I think what I just did would make more sense if we had already done this. Okay, so let's look down here. Actually, I'm going to start with this one. So on this one, we're saying this is the sum as m goes from 1 to 6 of 10 times 1/2 to the m minus 1. Okay, so my first term will be 10 times 1/2 to the 1 minus 1. My second term would be 10 times 1/2 to the 2 minus 1. I'm now plugging in 2. My third term, I'm going to plug in 3, is going to be 10 times 1/2 to the 3 minus 1, plus 10 times 1/2. The good news is I'm not going to expand all of them, and I'm not going to ask you to expand all of them, but I want to illustrate what exactly is happening to the 5 minus 1. And then the last term, 10 times 1/2 to the 6 minus 1. And so this is, I have taken, I got bigger as I wrote. I started with this value of 1. I plugged it in here. I plugged in every integer until I got to this value of 6. I plugged in that 6 and then I stopped. Okay, so you'll notice how many terms are there. There's 1, 2, 3, 4, 5, 6 terms. And then the summation, okay, well, this will be a little annoying. This first one is 1/2 to the 0 power is 1, so 10 times 1. This is now half of 10, which is 5. This is half of that, which is 5 over 2. This is half of that, which is 5 over 4. This is half of that, which is 5 over 8. This is half of that, which is 5 over 16. We can check and see if we agree with that. 1/2 to the 5th power is 2, 4, 8, 16, 32. So this becomes 1 over 32 times 10, which then is 5 over 16. Okay. I don't need that in my notes. And there you had to watch me erase it. So the summation would be what we get when we add all those up together. I don't really want to do that. Okay, I will, for you, I will do it. Let's see if I have, there's Desmos. I had 10 plus 5 plus 5 over 2 plus, oh, nope, let's try that again. Plus 5 over 4. Plus 5 over 8, plus 5 over 16, if I remember correctly. Okay, so here we just got 19.6875. Or, actually, I got excited. I didn't realize this before, but that button over there changes it to a fraction. And fractions are often very nice to work with. Okay, what we will find is, over here, I can also use my formulas. So this is a geometric series where my first term, a sub 1, is equal to 10. My common ratio is equal to 1/2. And so I can use the formula. You know what? I'm about to make all this smaller. Okay, there's that. I can now use the formula S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. And we can say, well, the first term we said was 10. We have a common ratio of 1/2, and we're finding the sum of 6 of them, so that's to the 6th, minus 1 over, there we go. So let's pull up Desmos again. Come back, Desmos. Let's see if this gives me the same thing. 10 times, I'm going to make the fraction 1. I need to divide, so then this is 1 minus, well, 1/2 or 0.5. Okay, so coming up here, minus 0.5 to the 6th power. Okay, and do those numbers match? They sure do. So this is, I really like that fraction, which is 315 over, but not 6, over 16, which was, you could tell me, it's also equal to 19.6875. And we found it both ways, which was kind of cool. Okay, let's see. Now, I'm kind of working backwards in the notes because I didn't write the notes, and this way it makes more sense to me. So in the next one, I don't know that we're going to do that one. On the next one, we're going to start here. The first number, remember, we start with this number, we plug that in, and we plug in every number until we get to the top number, and then we stop. So this first term is 3 times 10 minus 5. That's the first term. Plus, I'm going to put those in parentheses. The second term, 3 times 11 plus, nope, not plus, minus 5. Plus, here comes the next term, 3 times the next term, that would be a 12 minus 5, and then I have plus 3 times 13 minus 5, and then I get to 14. 3 times 14 minus 5. I plug 14 in and I stop. Okay, so how many terms? Well, here's where you're going to go wrong. You're going to tell me it's 14 minus 10, there's 4 terms. But look and see, 1, 2, 3, 4, 5. There are 5 terms. So what you have to do is you have to say 14 minus 10 plus 1, because we need to count both the value, the term that has a 10 and the term that has a 14. So if we subtract them, we will be off by 1 every time. Okay, so be careful with that. So now, if I were to find this would be 30 minus 5 is 25. 33 minus 5 is 28. Oh, we're adding 3 each time. 31, let's see, 36 minus 5, yep. 39 minus 5 is 34, and that's 3 bigger than the last one. And then, what am I at? 42 minus 5 is 37, which was bigger than that previous one. Okay, okay, let's prove it to you on Desmos. Come back, Desmos. Those are lovely and gone. I have 25 plus 28 plus, make sure I'm typing this in correctly, 31 plus 34 plus 37. Okay, and I just got a sum of 155. But there is a faster way to do this where I don't have to expand all these terms. And that's using the formula, well, so I can use either one. I can use either one of these two formulas. So I knew the first term, well, I have to know the first term in either formula, and I know the common difference, so it just depends on which formula you want to work with. On this one, you know what, here we go, we're going to shrink all this, give ourselves more space. There it goes. Okay, so what I know in this particular problem, I know that my first term, is that not actually my first term that I care about? It's not term 1, it's the first term I care about, which happens to be a sub 10. When I plug in 10, I get 30, I get 25 is the first term I care about. The last term I care about is actually the 14th term. Plug in 14, we had 42 minus 5 was 37. Okay, so we're going to take this formula, S sub n equals n over 2 times a sub 1 plus a sub n, and we're actually tweaking it a little bit. Think of this as not the first term of the whole series, but the first term, this is the first term we care about. And this is the last term we care about, and this is the number of terms. Okay, so for our particular scenario, we're going to say the sum of, well, this is 5 terms, is equal to 5 over 2 times the first term we care about plus the last term we care about. Come back, Desmos. Oh, I wanted to keep that. Oh, well. Oh, I can undo. Ha! Sorry, easily amused. Okay, so 5 over 2 times 25 plus 37, and notice they're the same. And so in the future, it wouldn't be so terrible to write out 5 terms. I mean, it's a little annoying. It took me, a little bit of time, a little bit of space. I could do that, though. But I'm going to give you problems where you can't write out all the terms, and I'm going to ask you to use the formula here and then find that this is 155. So what do I want to see? I want to see you write down the formula. I want to see you plug in the numbers, and I want to see your answer. Okay? So if you try and do more than that, I am not going to give you full credit. Okay, but I will show you this on Desmos now. There is a way, if I go to functions, I can go, there it is. So there's my sigma. I can say as n goes from, we were doing 10 to 14 of, and now I need parentheses. What was it? 3, I have to go find n. 3n minus 5, and there's my same answer. Okay, and so yes, that is very cool, but if you rely on the summation, use that to help you check. If you rely on it, I won't give you full credit. I'm not sure if I'm going to give you half or a third of credit. I might just give you a third. I'm going to talk to Miss Bellish and see what she's going to do. But these right here, done. Sorry, I could do this later, but if I don't do it now, I'll forget. Let's see if I can add that. Oh, too big. Go away. Go away. What have I done? All sorts of crazy things. Sorry. Okay, so here is that right there. Okay. The next one would be, well, let's just talk about the number of terms. So I see that I'm plugging in 3. I'm going to plug in 3, 4, 5, and 6. So that's 6 minus 3 plus 1 gives me 4. And sure enough, when you count 3, 4, 5, and 6, that gave you a total of 4 terms. I don't really want that in the notes. Delete. Okay, but I don't really feel like plugging that in right now. Let's just talk about that has 4 terms. Super. Okay, so now that we understand sigma notation a little bit better, now we can go back and write that material in sigma notation. Okay, so on this one, once I found the nth term, then I can take the nth term and put it here, and then I wanted to go from n equals 1 to n equals, so there was 1, 2, 3, 4 terms, and so I went to 4 right here. Let's do one more together. On this one, what do I notice? I added 8. Oh, I added something big. Okay, so I'm going to multiply by 3 this whole way. So this is geometric, and it's infinite. And so what we will say here is that this is the sum as n goes from 1 to infinity, because it's infinite, it keeps going, of, well, if you remember the geometric g sub n is equal to g sub 1 times r to the n minus 1 is one way to do this. And our first term was 4. Our common ratio was 3. And this is a lovely way to write this. And there we go. That is the sigma notation for that particular problem. Okay, what else do I want to cover? Determine if they will converge or diverge. On this one, if it's arithmetic, as soon as we see arithmetic, it will diverge. And that's arithmetic. With the d value is 4. So on this one, we are taking a fourth, a fourth, a fourth. Oh, okay. This is geometric. That's an O, pretend. And our r value is equal to 1/4. That is, 1/4 is less than 1. So we are good to go. This will converge. Okay, this one, I am multiplying. Oh, I'm getting bigger and bigger. R is equal to 3. I'm multiplying by 3. If my R value is bigger than 1, my series diverges. The next one, oh, what's happening here? My numbers are getting smaller. Let's see. Is 500 over 625, is that equal to, question mark, 400 over 500? Let's see. It's a Friday afternoon, and it's been a long week. I'm going to let Desmos help me. I'm sorry. Well, and then I'm also, oh, here we go. What were we trying to say? 625, is 625 over 500 the same as 400 over 500? I did that wrong. I'm so sorry. Go away. Let's try that again. Oh, okay, there's that one. 500, I needed to do the second term divided by the first, and I did the first divided by the second, so my apologies. Yes, they're the same. Okay, and that R value is 0.8 or 4/5, would be how I would prefer to write that. So do they equal? Yes, they do equal each other, and they equal 4/5, which is less than 1, which is good, so this will converge. Okay. I think that's the end of the notes, and I will post the cartoon, and I'm really, 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 you got to watch it. It's amazing. Okay, so like, subscribe, comment, and go practice. Good luck to you.